Welcome to another TwinCAT tutorial from ControlX. Today we'll be looking into TwinCAT PLC visualization. We will explore the concept of visualization in TwinCAT and learn what it is and how it's used. In this tutorial, we'll learn to create a new visualization from scratch for an application by adding graphical elements to represent the process variables. Then link the graphical elements to the PLC variables in our project. And finally, we'll run the PLC and interact with our application through the visualization we just created. At the end of this tutorial, we'll have a better understanding of PLC visualizations in TwinCAT, how they work, and how to create and use them in your PLC projects. So let's get started. Let's begin with the obvious question. What is a visualization in TwinCAT? Simply put, it is a user-created graphical representation of the project variables, which allows inputs to the PLC program in online mode via mouse and keyboard. The TwinCAT PLC visualization editor provides graphical elements which can be arranged as desired and can relate to project variables. In online mode, the look of these elements can be made to change depending on the values of the associated PLC variables. We can pick the appropriate graphical elements from the toolbox that best applies to our application to build the visualization. The toolbox offers many types of input elements like text boxes, sliders, push buttons, and wide variety of switches. Similarly, there are many choices for output elements like lamps, meters, progress bars, text boxes, etc. In addition, there are numerous other control elements like checkboxes, radio buttons, scroll bars, histograms, bar displays, and many more. Let's see some examples of HMIs created with TwinCAT visualization. I created this interface for a dyno motor control test system. This allows us to manually run the dyno system from within TwinCAT for commissioning and troubleshooting purposes. As a troubleshooting aid, I've provided various areas in the visualization with useful information that can help quickly diagnose issues with the system. For example, this area shows the status words of the two motor controllers called M1 and M2. All the relevant OK bits are shown green, which light up when the bits have a value of true, and stay dim when they are false. Similarly, the fault bit is shown in red and lights up when a controller is tripped or faulted. This area shows the relevant system feedback like actual rotational velocity in RPM, actual torque generated by the dyno, motor current, and so on. Additionally, diagnostics information like zero speed, overspeed, NC faults, etc., as well as hardware enabled control is shown here. The mode of operation selection can be made here using the radio buttons, and the relevant control status of each drive in the dyno system is represented with the three indicators. And from here, the actual set points for the dyno can be entered by using these knob controls. As the knob is turned, its value is communicated to the drive and also displayed in the text box below. Here's another visualization example from the same TwinCAT project showing the overview of the entire process. This area here highlights the status of the lubricator subsystem. The two charts here shows the real-time measurements from the vibration sensors mounted on the dyno. It visually indicates if the measured values are within tolerance, and any spikes above acceptable thresholds will result in a warning or fault. This area highlights all the safety implemented on the machine. These safety indicators light up green when they allow the machine to run and highlight red when a safety component trips. Their location indicates where the fault occurred in the process. I have also used yellow to indicate warnings, which may escalate to false if not addressed. In addition, the lines connecting the various components shown here in gray get highlighted and become more prominent as those subsystems are enabled and become operational. So you can see TwinCAT visualizations make it so much easier to see the PLC variables visually and gives a more intuitive understanding of the process and machine operation without having to go through the PLC program code. If done properly, the visualizations can make troubleshooting and diagnosing machine issues so much easier. Now that we have an idea about TwinCAT visualization, let's make one from scratch for an existing project. Let's go over the project concept first. Imagine we have a machine with a drive controlling a motor. The system controller is a PLC. In order to run the system, it will need control inputs from the engineer. To be able to assess the system, the engineer will look at the notifications sent back from the system. The control input will consist of variables like drive enable, start stop, reset, mode selection, and various set points. Notifications from the system will consist of variables like various status bits, as well as speed and position feedback, among others. Now let's go deeper into the concept and review from the application point of view. We need controls for the drive to enable, start, stop, and reset the motion controller. For that, we can implement a control interface as shown. These switches can be tied to Boolean variables in the PLC and used for the corresponding actions. We'll be using LED indicators to visually indicate the state of the status variables related to these actions. For the mode selection, we'll use radio buttons, as these allow only one option to be selected at a time. Next, we need some means to enter motion set points. For that, we can use text boxes for user inputs as shown. Similarly, we will need to display notifications regarding motion status to inform us if the axis is moving or accelerating, or whether it has reached target position, etc. And finally, we need feedback to display actual speed and actual position. For this, we can just use text boxes. Once we implement these graphical elements, our visualization should finally look like this. Okay, enough talking. Let's hop onto TwinCAT and get started. We have our project opened. As you can see, this project has a motion component. Under axes, there's one axis. In the PLC, we have our training PLC. We have motion control loaded on the PLC. So this program controls this axis. This is the instance of the function block controlling the axis. Let's control the axis directly from the PLC at first. I'm going to open this and pin this here and log in. In order to run this, we need to enable it. As you can see, 3 check marks here, and the status says it's ready. It's executing a move called move absolute, where it just needs a velocity and a position set point, and it'll get to that position using that velocity. I'll put a velocity of 50 and a position of 65. Once we write these, it's now sitting at the new position. To disable, we just write a false and write values. So this is how the motion controller is being controlled through the PLC. But this is not fun to do all the controls by manipulating all these different variables. So let's create our visualization as discussed. Let's log out. Right click on Visuals, add visualization. Let's call it and click open. So it gives us a blank canvas where to design our HMI. Using the toolbox, we can design our HMI. So let's get started. First, we need some switches. So I'm going to drag and drop some push buttons. This will be our drive enable, stop motion, and fault reset. We need some labels. We need some LEDs. So go to toolbox, under lamps. Now once you drag one, you can copy and paste. Next, we can align them all. Select all LEDs, right click, alignment, align left. Same way we can align the switches. Same way we can align these 3. Let's label them. To change the text, move your mouse until the cursor becomes an eye, and then change the text. Alternatively, you can click on the label, go to the properties, and we can change the text property from here. I want the horizontal alignment to be left and the width to be 100. Now, if I want to reposition these, it's very hard to manipulate them individually, as that will disturb the position with respect to the other elements. So we can undo this. What I'm going to do is put them all in a group box. So you can draw a group box. Now, in order to put these in a group box, I find the best way is to select them all and group them. So now this becomes one unit. Put it inside the group box. Now once you move the group box, it moves the components inside, and then you can ungroup them. My group box still contains all those elements. Next, I want different colors for the lamps. So for the drive enable, I want green. So you click on the component, go to the properties, and one of the component here is the background color. By default, it's yellow. This I can select and change to green. This one I'll keep yellow. The fault reset, I want red. I can also change the name of the group box. Next, we want to link the PLC variables to these controls. We'll start with the lamps. Click on the lamp, go to the properties, and one of the item here is variable. So let's link our variables. Similarly, let's link these switches. There. Also, I would like to change the color of the drive enable. The switch itself illuminates. Default color is gray. I'm going to change that to green. Let's see if this thing works. So let's log in. As you can see, the motion is currently displaying that it's stopped. Let's open the axis, put them side by side. So I should be able to enable from here now. Yes, we can see the controller has enabled, and the ready status bit is reflected on the LED here. Let's go ahead and add the motion select radio buttons. Always make sure you're logged out. I need one more radio button, so we can click create new. Next, we need some text boxes for the set point inputs. Next, we need some indications for motion status. For that, we can just use rectangles. This one will indicate when the motor is moving. So let's give it the text called moving. And let's give it some color properties. So we want the frame color to be black, and we need the fill color to be dark green. There is a dark green, but it's not dark enough for my liking. So what I'm going to do is click that, then click the three ellipses here, and we can create our own green button. So I've created some custom colors here. This one has green of 90 on a scale of 0 to 255. So we'll go ahead and use that. So when the bit is false, this is the color we're going to see. And when the bit is true, I want to see the alarm state color, which can be this bright green here. And we'll keep the same frame color as black. Next, I'll copy this and paste it. And this will be the not moving. Now, because it's a copy of the moving button, it has the same properties, except I don't want it to be green. So here I'll pick a different color. When it's true, it'll be light blue. And when it's false, I want it to be dark blue. I'll go ahead and link the variables. So click on the first one and go to color variables. And here we can assign the PLC variable. Similarly, I'm going to add the remaining indicators. Let's link the variables. Now let's get back to the text boxes. We have not linked them to any variables yet. So let's do that. So for the text boxes, you have to go to text variables and link the variable here. In order to display the text, you have to format it using the formatting assignment as shown. And we can see our live values are shown here. Now these are still read-only. We have not given it input assignment yet. So let's do that. Click on the text box, scroll down to the input configuration. On mouse click. So from here you can pick an action that would be executed when the mouse is clicked. In our case, we want to write a variable, and we will choose use the text output variable. Now if you notice, the text output variable is this one, so we will use the same variable. And there are some input types available for us. You can do text input with limits using numpad. In our case, we'll just go with text input with limits, and we will define our minimum and maximum of 300 RPM. And the dialog title will be enter speed. Same thing for the other two. Let's test it. Okay, it doesn't like something. So let's go back and take a look where we went wrong. Has to be in single quotes. So it doesn't take any value higher than 300 because the max defined was 300. Now I'm giving it a different position. So it did move, and now it's not moving. Let's try that again. So it was accelerating, moving, but we can't see the live value because we have not provided any means to display the live values. So let's do that. Let's name our group boxes. This is looking too basic, so let's tidy it up. First, I'm going to change all their titles to a slightly larger font. Change the font color to green for all the inputs, and for the outputs, I want to change it to blue. I haven't linked the radio button, so let's do that. And that's everything. Let's run. My selection is absolute positioning. Let's do position of 125. Moving LED is indicating. Now it should decelerate, and it's in position. Let's try relative positioning. And I'll tell it to do, from here, do a motion of 25. For the relative position, there's another input that I'm missing. I'll have to add that button here. So we'll get back to that later. Let's try the velocity control. So as soon as I switch to velocity control, it's spinning with an actual speed of 55, which is from our set point. Let's change it to 100. It accelerated to 100. Now my axle decel is set to 0, so it's using the default value of 1000. So I'm going to tell it to do an acceleration of 25. Let's give it a different speed. So now it's doing acceleration at this rate. And now it's in velocity, as my actual velocity is 200. Now I know this doesn't look very aesthetic, so I'm going to go offline, pretty this thing up, and I'll be back online. And we are back. So this is what I came up with. Let's give this a try. It's moving in velocity mode. So let's stop it. Let's try relative positioning of 25 with respect to this position. So let's do a trigger move. And it incremented by 25. Let's see how we can use the fault reset. So if I go to velocity mode and let it spin, and I'm going to remove the controller enable. That stops it. So we can use this fault reset button to reset the fault. Go back to enable, trigger move, and it's working. Coming up in the next tutorial, I will be introducing you to TwinCAT measurement projects. We will explore the various measurement project types and learn how to use them in our PLC project to visualize live data. That's all for today's video. How will you be using TwinCAT visualization in your projects? Please do share your ideas in the comments below. If you found this video helpful, then please consider subscribing so you don't miss out on future tutorials. As always, thank you for watching and keep innovating.